The last set of videos for this module about chemical kinetics are actually not about chemical kinetics. They're about reactions, they're about kinetics, but it's not chemical change, it'll be about nuclear change. The nuclear reactivity can be studied with the same tools that we have used to study chemical reactions. And to understand a little bit how nuclear reactions take place and why they are so energetic and the kinetics of it, it's important to first understand that in the periodic table there are different kinds of atoms. We can classify the atoms, or from now on I'm going to call them nuclei because that's what we care about, the stability or instability of the nucleus of each atom. So there's three main kinds of nuclei in the periodic table. Some of them are stable, meaning their nuclei, the combination of protons and neutrons are such that are stable for a long time. Others have a combination of neutrons and protons that is unstable. We are not going to talk about the laws that decide whether specific combinations of neutrons and protons are unstable, but some are really very short-lived. They can be synthesized in the laboratory, but they do not last longer than a fraction of a second. And others, while being unstable, they take a long time to really disappear, to decompose, if you will, and we call those radioactive. And typically there's certain areas of the periodic table that most of these elements are just synthetic, they are very unstable. There are some combinations of neutrons and protons, and for example carbon, there is carbon-14 that, unlike carbon-12 or carbon-13, carbon-14 is radioactive. It's not unstable. You all have a certain amount of carbon-14 in your body, and it lasts for thousands of years, but it doesn't last as long as a stable product, a stable nucleus. So the periodic table is full of specific combinations of protons and neutrons that give as a result a stable or unstable or radioactive nucleus. So what are the main differences between nuclear reactions and chemical reactions? Mostly is that in a nuclear reaction atoms are converted into another kinds of atoms because the number of protons and neutrons change. What defines an atom is its number of protons, therefore it changes its identity. Also, you may not think about chemistry. The electrons will not take much of a part in nuclear reactions, but what's very important, and probably you already know, is that there's a large amount of energy involved in these kind of reactions. This is why we use nuclear power plants to absorb the energy and apply it for other purposes in society. So let's just study very briefly, the kinds of nuclear decays that one can observe. When one has an unstable nucleus, and we will study different kinds of them, it will decompose into something else, and depending on the kind of radiation, the type of radiation that this nucleus emits when it decomposes, it will convert into something else. So what kind of radiation it can emit? It can emit alpha, beta, or gamma particles. And in terms of alpha, beta, and gamma, as you go down, the energy is typically, sorry, not the energy, the mass. The mass is lower, so being alpha, the most massive particles is actually a whole nucleus of helium, 2 protons and 2 neutrons. And gamma is just a photon. However, it's easier to protect from alpha. Remember that just some cardboard can protect you from alpha radiation because it's so big that any screen can, specific types of screen can protect it. However, gamma rays penetrate very much, so they're also very dangerous. You're not supposed to memorize all of these. You have studied this in the past, but just so you know that there's different kinds of decay. There's different kinds of nuclear reactions depending on what type of radiation that nucleus emits when it becomes products. Okay. In this slide, there's a little bit more of the detail. You may just read this. Again, you're not supposed to memorize it, but at least understand that there's three main different kinds of nuclear decays. What's important, and that's the main objective of this video, is to understand that like a chemical reaction, a nuclear reaction has also need to be balanced. So for example, you have here bismuth 209. Notice that this number and bismuth is redundant information. All bismuth have 83 protons. This number up here is the combination of, and this is the number of neutrons, this number here is the combination of protons and neutrons. So in this case, bismuth decays emitting an alpha particle, in other words, a nucleus of helium, and it means that this bismuth atom loses 2 protons and 2 neutrons. The question is, what is the result? Well, in this case, if it loses 2 protons and 2 neutrons, whatever it is here, it will have 81 protons. If you go to the periodic table, the element that has 81 protons is thallium. Okay, so we can only have these two options. And now we have 2 neutrons and 2 protons. It means that our mass number needs to be 205. So this is the right option. Notice that to balance an equation, still matter needs to be conserved. It's actually not exactly true. Matter will not be conserved because there will be a lot of energy, but we will talk about that. But definitely the number of protons and neutrons need to be conserved. So that's pretty much the objective of this video. Make sure you can balance nuclear reactions.